Hello and welcome to Trevor's Tutorials. I'm Trevor Slocum. In this tutorial, we'll take a closer look at the architecture of the EbiTengen game engine. We'll learn how our game loop is single-threaded by default, how EbiTengen maintains the tick rate, or ticks per second, and how all image surfaces in EbiTengen share the same type. At the end, I'll also share a few reasons why I enjoy using EbiTengen to create video games. I'll also demo a couple of libraries created for EbiTengen. As we learned in previous tutorials, EbiTengen periodically calls our game's layout, update, and draw methods. Only one of these three methods is ever called at any given time. So in effect, when looking at just these three methods, our game runs in a single thread. Still, we can and should make use of more threads in our application because modern devices have more than one CPU core, and so adding those extra threads will make use of those extra CPU cores. To maintain tick rate, EbiTengen runs a loop which constantly checks the current time and compares it with when EbiTengen last called the update method of our game. Based on the tick rate, or ticks per second, which we've configured, and the amount of time that has passed, EbiTengen may need to call the update method 0 times, 1 time, or more than 1 time. Here we have an example game running at 60 ticks per second and being drawn at 120 frames per second, and we can see there's one update call and then 2 draw calls before update is called again. Note that based on system performance, especially fluctuating system performance, you may see a fluctuating tick rate and a fluctuating frame rate for that matter. In EbiTengen, all image surfaces are the same type, EbiTen image. This goes for the screen canvas that we draw onto and is shown on devices' screens, and it goes for any off-screen images we create which are never directly shown on the screen. This is nice because all draw operations we can perform work the exact same whether we're working directly on the screen or if we're working with off-screen images. The only difference is the screen canvas, when it's shown, is scaled up or down automatically to fit the window, and when it's scaled, it maintains the correct aspect ratio. Now I'd like to share a few reasons why I enjoy using EbiTengen to create video games. EbiTengen's API design is simple, and this has a number of benefits. It's not just easy to understand. By having a smaller API surface, EbiTengen is able to support a wide number of platforms. I'll read the list now: Windows, macOS, Linux, FreeBSD, Android, iOS, WebAssembly, meaning running in the browser, Nintendo Switch, and Xbox. I have not developed a game for most of those platforms, but I think it's impressive that EbiTengen is able to support all of these different devices. EbiTengen's API is simple, but I think this is one of those less is more situations. The community of developers using EbiTengen fill in the gaps, and these different developers have unique perspectives and approaches. What this results in is we typically have multiple options for solving any particular issue, and these different options have their own set of pros and cons. I also appreciate how EbiTengen is available under a permissive software license, the Apache License 2.0. I don't want to get into the details of this license, you should go read the document, but I would like to highlight two aspects of it. You are not required to share the source code of your application, nor are you required to pay any fees or royalties. This stands in stark contrast with some other game engines, where you might not even be allowed to share the source code of your application, or you might be required to pay some amount for each installation. If you would like to support EbiTengen, you can find out how at ebitengen.org. Lastly, I'll highlight 3 libraries for EbiTengen. This first library I created, it's called ETK, and it helps with creating graphical user interfaces. In this screenshot, we can see some of ETK's widgets and layout mechanisms. Next, Raycaster Go by Harbdog is a raycasting engine which allows you to create pseudo 3D games. Also, Tetra 3D by SolarLoon allows creating true 3D games. You can find these libraries and others in the awesome EbiTengen directory. In the next tutorial, we'll learn how to create and load tile maps using the EbiTengen game engine. See you there.